So good morning, everyone, and thank you, Brian. As Brian said, we're going over energy at the speed of growth today, and I'm going to let each panel member introduce themselves, and then Jim is going to kick it off, and then we're going to start with some topics and questions that we have prepared for the panel. So let's go ahead and Marshall, do you want to introduce yourself?
Absolutely. Good morning, everybody. I'm Marshall Williams of Newfront Insurance. I tell people I insure nuclear reactors.
I'm Andy Browning with Duke Energy, and I'm the VP of our gas generation projects.
Lloyd Patterson, Business Unit Director for IPI, Mission Critical Space. We also have another sister company called Inogen, where we do behind-the-meter power design construction.
Jim Ellis, Chairman of the Board for CURT, and also retired Corporate VP for Microsoft.
Okay. And Angela Scow is CNA, Vice President over Construction, Large and Complex Risk, and also a member of the Board of CURT. And so, Jim, I'm going to turn it over. You come up and let me get your slide ready. There you go.
Very good. Good morning, everyone. I know you can hear me. That's loud. Yeah, step away from that, baby. So this is a pretty relevant topic for all of us sitting in the room here today. How many of you in the room are facing some challenges with getting power to the projects that you're delivering on? Show of hands. Just one. That's odd. Okay. Two. I see two. Three in the back. So this topic is all about time to power, which we're seeing in many market verticals being time to market. And there's a lot of challenges that are out there, and you might say, well, why do those challenges exist? Well, we're growing so fast in a lot of these verticals that it's hard for the electrical demand to keep up. It's not about the ability to provide electricity. It's really about the ability to deliver it with speed with all the growth that's going on, not only in the U.S., but across the globe. And you're seeing similar kinds of issues sitting in Asia to some extent, with the exception of China. You're seeing some issues, obviously, in the European community. And then you're seeing a lot of those issues here in the U.S. When I was at Microsoft back 3 or 4 years ago, there was clearly an opportunity to kind of broker, purchase power agreements in a fairly decent time because that informed site selection. But right now, that's not the case. We're 5 years away from securing, and a lot of times, new grid power. The transmission is probably a critical path on that, so we haven't kept up the transmission capabilities in the U.S. And clearly, this is becoming a challenge across the board. So if you look at the chart here, what are some of the challenges we see? Well, look at the growth curve that we expect to have globally in electricity demand going through 2030. It's going to more than double in terms of thousands of terawatt hours. And everybody kind of says, oh, we're going to blame that on data centers, but you can point at data centers, which are going to grow from probably today at a 4% total of the total electrical demand globally up to somewhere by 2030, 8 to 10%, depending on what statistics you look at. But the bigger challenge is it's growing across all verticals. And so it's not just a one, vertical issue, although data centers take a lot of blame for the fact that, you guys are taking all our power, we're subsidizing you, data centers in our communities, so forth and so on. Not only that, we're subsidizing water. But at the end of the day, this is the challenge we're facing. And it's just not really a single vertical issue. It's really a multiple vertical issue. So we're going to talk today, I'm going to turn it back to Angela here, and we're going to get at least to the point where we kind of share what the issues are, and more importantly, what are some of the solutions that we have. And we talk about behind-the-meter strategies, that kind of give us independence from the grid. We talk about the progress on SMRs and how that's progressing. So with that, I'm excited about the panel, and I'm going to turn it back to you, Angela, for the rest of the team.
Okay, great.
Thank you.
Get your mic.
Thank you.
Thanks, Jim. All right. So, as Jim was talking, I mean, we're in a market that is growing so fast, and the pace is more than we can keep up with. I know from an insurer standpoint, we are getting projects in weekly of data centers, large campuses that are coming up. People are looking at building, core and shell, and we'll worry about the power later. It's a crazy world that we're going into. So, I would ask the panel, and Jim, I'll start with you. So why is this, this the first time there's not enough energy to go around for the new industrial projects?
Yeah, so I think we're going to pivot to Marshall here first, if you don't mind, because he wanted to share a little bit first on that,
Sure.
Angela.
Yeah, I'm happy to kick us off. So, quick question. Does anybody know how many data centers there were in 1990? Just depending on description, the answer is 0, right? And there were 27,000 mainframes in the US at that time. 90% of them were owned by IBM. At the same time in 1990, there were 112 operating nuclear reactors in the US. Now, as Jim's highlighted, there's 5,426, from numbers I could pull yesterday, data centers in the US. We're going to talk about AI, we're going to talk about advanced manufacturing, but as that's happened, there are now only 94 operating nuclear reactors in the US across 54 concentrated sites. And so, of course, we've electrified industry, transportation, reshored manufacturing, we've, tightened standards that we're held to environmentally, and all of that's very important and helpful work. But the key point is this, and I want to ground us in this, is how we consume electricity has fundamentally changed, and the needs on the grid are very strained. And so it's moved from, following consumer behavior, right? You get home, you turn on the lights. You get home from work, you turn on your TV. It's cold, you turn on your heater. Cold weather, lights, TV. But the grid is built for this kind of diversified, interruptible, demand. AI and advanced manufacturing have totally different demands, and this is what I call load profile inversion. Basically, each of these is requiring, nowadays we require deterministic, non-interruptible power, and that's not what the grid is built for. And so, that increases risk. We're going to talk about where that came from, but that's what I want to start us with.
Okay, all right. So when you're talking about non-interruptible power, and we're seeing, I'll say, when we're seeing project business come in, they're looking at powering with wind, with solar, with connecting to existing grids, or putting in, alternative energy. So, like you said, we've only got so much around. And so what constraints are currently limiting energy availability in the market? And, how can that impact our future projects? Not just in data centers, but as Jim alluded to, there's more than data centers that are going up.
Absolutely. I think that's the one I just answered. So, Jim, you want to take that?
Sure. So there are constraints here, right? So we talk about a lot of these constraints. I would say the first constraint is the actual permitting process as one. And I don't know how many of you have been involved in the room in having to get permits over the line for your capital assets, but, electrical power is no different, right? So the regulators actually are weighing in here in a real way. We have all kinds of state regulations that we have to apply by, as well as federal. And when we don't have a kind of what I'll call a seamless kind of integrated process across permitting, it kind of drags things out. And it kind of goes also into the whole community right to operate piece when we talk about permits. And we had a lot of discussion at the panel as we were preparing for this and how important that really is for us in the room to understand that the community indeed gives us the right to operate. And I learned that way back in DuPont when I was there, and we couldn't get assets through the permit process unless you were actually proactive in getting the support of the community, you were going back and giving back to the community. You made that a definitive part of your strategy. And if you didn't, you kind of suffered the consequences, either being delayed significantly or you had all kinds of resistance if you're going forward to get incentives, for example, on the project, tax incentives, things of that nature. So that's one of the bigger constraints, but I'm interested in other people's perspectives as well.
Yeah, on the permitting side, some states are taking a lot more proactive approach. Saw that in West Texas, they actually got permitted 7 gigawatts in about 6 months. And the way they went about the permit was quite unique. They basically said, hey, here's a range of assets that we're going to put onto the grid. We're not sure which ones yet, but this is going to be the emissions criteria that we're going to use, and they actually got it permitted. So there's some states that are, and locales that are being a lot more aggressive in their permitting approach, and there's others that are being a lot more restrictive. So that's certainly one of them. And then back to your comments, Jim, on the community engagement, some of the things that we've had to do to really make sure that we're in alignment with the local community leaders is really upfront having those town hall meetings, council meetings, not just engaging with the local leaders, but everybody in the community and getting their full buy-in and support, because they can really helping them understand what the positive impact to their community is going to be for some of these, right? I mean, some of these we're building massive campuses and very remote locations, right? I mean, we're going to build towns out of nothing practically in some cases. So those are very important, and because somebody, hey, I've got a town of 1,000 people, you're telling me you're going to bring 5,000 craft. You know what I mean? So, and so some of those things of how are you going to make sure that that you don't overwhelm us and that type of thing. So those are a lot of the real considerations.
So, and Lloyd, I think you did a lot where you've done town halls, you've been out the community outreach. As far as you can get ahead of that, the better off you are.
Correct. I mean, career fairs, providing opportunities. Hey, bring your business cards, bring your resumes. We're having a career fair on a project I'm working at here in a couple weeks. Just saying, hey, we're bringing opportunity to you. It's not we're not here to take, we're here to give, right? Not only for careers, but to the fire department, the police department, right? How are we going to actually improve the infrastructure? What are we going to do for the schools? I saw where Hani Noshi with Microsoft just posted a couple days ago where Microsoft's come out and said, hey, here's our, basically our 5 bullet points on how we're going to do community engagement going forward. And I think that, I think that's been a long time coming, because I think for a lot of places it's been more heavy-handed. We're here and we're going to do what we want to do, and that's caused there's been some, I will say, some bad actors that have caused some black eyes for the space. But I think we all wrap around our heads around these kind of things will help out tremendously.
Okay.
And so I'll expand a little bit on what Lloyd commented. For us, it's early engagement with the community so they understand what's going on. But then as we decide which contractors we're going to use to build our facility, bringing them as well, because again, you're usually going to do this in a rural area, and so where's your workforce going to come from? How are you going to house the workforce? Teaming up with the local community college or whatever tech center they might have nearby so you can set up training programs. And it's been good where the contractor will come in and say, we're going to help you set these up, and we're also going to provide assets as far as personnel and equipment for you to help train them the right way so they'll not only help us build our facility, but have a career when they're done.
And to add to that further, Dr. Basu brought up a great point, and I think, Lloyd, you reiterated this, is that I think that, back in the day, the coal plant was what built the town, right? That's where you got your high-paying jobs. The data center is the modern equivalent of that. And so I think we've lost a little bit of sight of that in how we kind of frame community engagement now. It has to start there, right? We were facing NIMBYism, and we're going to talk about community engagement. While we're on the note of constraints, Andy, you'll really hit on this later, but we just got to talk about EPC schedules and those kind of things as well, because, right, like, EPC schedules are no longer dictated by field productivity. It's, they're dictated by equipment, timelines, delivery, lead times, right? And we're facing massive OEM backlogs. We're facing, balance sheet constraints, dominating timelines. There's a lot to open up here.
Angela, I want to build in a little different direction. We talked
Okay.
a lot about permitting, but I want to talk about the market a bit here too, and just kind of illustrate what's going on as an example, vertical with data centers, right? We're in a war on AI, and we got to win it here in the U.S. What does that mean? We're seeing upwards of 30 to 35% compounded annual growth rates in data centers. Think about AI as being kind of the fuel, and the data centers as the gas station. And we got to build a lot of these assets here if we're going to actually be able to compete on a global basis and be a country that basically is economically leading the world. And if we don't do that, we're going to find ourselves in quite interesting times. And so you see a lot of this kind of translating into this need for speed. But we're constrained. We're constrained in real ways. Everybody's talked a little bit about that, right? But the reality of it is, we've got to win this race on AI. And we have a lot of folks that are faking it to make it. But at the end of the day, it's still going to be with us. And we have a lot of great discussions on AI. I don't want to steal the thunder of other panels, but this is part of the big challenge of why we're seeing a lot of this power demand, at least in the U.S., really kind of accelerating.
So with the speed, though, Jim, I mean, we know like transmission infrastructure requires like a 7-year timeline. That doesn't sound very speedy to me. I mean, so how do we overcome some of that? And Andy, I'll let you address that because that's what you do.
Right now, you've got a lot of people that want to connect. And so they'll have to do a study for that area. Recent change that most transmission groups have done is now, rather than looking at each individual project, they're doing cluster studies to see what the impact of the collection of projects is going to do and what kind of upgrades are going to be required. There are times where they'll do the study and realize we can't do just an upgrade to the system. We've got to run a brand new transmission line. So then I've got to go find which path I'm going to take, what corridors, and then I've got to work right-of-ways, and it doesn't matter what path you take, you're going to get resistance.
Right.
And so it's doing that. One of the big things that has helped, EPRI developed a new cable that we can restring the conductors on a transmission line and double the throughput. So things like that. I think with the AI and technology, there'll be more innovations like that to help use the existing facilities to get more throughput. And that's going to be important here.
On the note of transmission as well, I'll add that, permitting frameworks specifically for transmission were built for incremental growth, right? And for context, a gigawatt, right? The days of 100 megawatt data centers are over. And so a gigawatt is roughly 700 to 750,000 homes. So we're seeing these huge stepwise increases in what energy is required, and I don't think permitting for transmission specifically is built for that.
No.
So, and, with the, we talked about community engagement, local leaders, city officials, state representatives, all of those are involved in the permitting and approvals. How do executive orders, how do you think those are going to impact the new gas and transmission and what we're looking to do in our economy?
I can start here. So I have a unique purview just because of family connections and politics. And, the executive orders are a great start, but we're still coming out of a 50-year nuclear winter, and no 4-year administration is going to change that. So executive orders, for NRC reform, right? I see more LinkedIn posts celebrating that people got all their paperwork in than groundbreaking ceremonies. And that's a problem, right? And the executive orders will help address some of those internal governmental changes that lead to positive regulation reform. And it'll also allocate funds, right? I don't know if anybody knows Chuck Fleischman, but he's the most popular guy in Tennessee because he's the only appropriator that can get these billions of dollars set aside for, water, nuclear, solar, et cetera. And so it's a start, but, as funds are allocated, how do you get access to them? How do you bid, right? And if you add a 2 to 3 year bidding process on top of the regulatory process already, it might not actually even be the catalyst that we hope it to be. And so all of these things need to work in tandem.
I'll just add to that, the regulations around air permits, the EOs haven't addressed it all. So even to be able to get the air permit done so that you can begin to get your site available, you're talking 2 years. You haven't even done anything yet, right? Mm-hmm. So, the fastest you could get one up is, let's say 6 years, and you're probably at blinding speed at that point. That's just not going to be, realistic in terms of, to Jim's point, of winning a war.
Mm-hmm. So, and Jim, you had mentioned about the amount of power. And in our discussion with our panel, you had mentioned that, worldwide, we're looking at an increase from 25 terawatts to 60 terawatts to support the power. And, that's massive.
It is massive, and probably the key question is how people dealing with that constraint, right? SMRs are not going to be, at least in the U.S., in the very near future. But let me tell you that most verticals want to have grid power as their supply because of the reliability. It's been proven, right? But practically not being able to get there requires industries to go and take a look at very different solutions to get this done. And that's where you see a lot of this behind the meter kind of strategies that are coming into play. It enables us to do two things. Number one, it enables us to put different solutions into play, integrate them together, go a lot faster than 7 years. And more importantly, we don't have to worry about the transmission because the transmission is right there on the site. Now, we still need backup power. A lot of these facilities have to run at, some of them in data centers are 5 nines reliability, not the power, but the actual operation itself. So how do you actually deal with that? And when you take that into your own hands, as a Microsoft or an Amazon or, an Alphabet or whatever, you're finding that you get, the power, you get the reliability and the redundancy that you need, because everybody in this room who actually is on their computer and the internet every night does not want to lose that.
Right.
So that's clearly what drives a lot of this, because it's all about the client at the end of the day. But these strategies are starting to play out in the industry to close the gap on the 7 years transmission and the 5 years generation. And will it stay as part of the long-term strategy? Probably not, because you see the gap closing, and I'll let Andy and others kind of comment on this, but we're probably in a 5 to kind of 10-year situation where we're going to catch up at some point in time. But in the meantime, these are the solutions that are going in.
Yeah, I agree. It's going to probably be 7 to 10. We'll catch up. But I want to hit on what they just talked about. So a terawatt, 1,000 gigawatts. You heard Marshall say 1 gigawatt is good for about 750,000 homes. So put it in perspective, yesterday for our company in the Carolinas we were projecting an all-time peak load, and that was about 40 gigawatts for the 2 states. So you're looking at 50 times that is what they're expecting to increase because of data centers worldwide.
So are you seeing owners collaborate with other companies to try to meet some of this demand?
Absolutely. So it's because it's so important to the country, we've got to get innovative in how we address the problem. And so it's don't do things the normal way. We've got to be different because speed is important. So it's working with legislators, working with different companies, coming in as a team. How do we solve the problem? And so you might think it's a crazy idea, but it doesn't matter. Throw it on the table because we'll look at it and it could possibly be the solution.
So with all of, the powers that we're looking at, you don't want to leave anything behind, right? Like you said, throw it on the table. So we're going to see where, power, it's not just a regulatory consequence. What about national security, depending on how some of these facilities are being run? When does that come into play over just operating your plant?
I can start here. So there's a lot of ways to take this. First of all, there's a lot of companies in the U.S. We're trying to reshore our manufacturing. We've friend-shored with France and other partners, but it's the first time where we have a lot of companies in North America doing only one thing, and they only have 1 or 2 people who can supply the parts for that thing. And if you think about this moment, right, it's the first time we've ever had people separate in their minds nuclear weapons testing from nuclear power, right? We haven't seen above-ground nuclear weapons testing in many, many years. And so if there's one slip up, right, so maybe it's a 25-year-old, engineer messes up, or some of these young CEOs, their company rushes, that will be catastrophic for the whole industry. This is like truly a no-fail mission. But from the national security angle, right, if you think about if we have one failure, the whole industry shuts down and we lose the piece of the pie that nuclear can represent, every foreign adversary has reason to attack us from a cyber perspective and other means. If you guys have seen live free or die hard, right? Where they shut down the whole country because they turn off the power, right? Like that is a reality now. And it's motivated because it doesn't matter that, Russia or some other adversary hacked our security and turned off a plant for a few days. That badly reflects on the whole nuclear industry, and that could be the one failure that pushes us back another 50 years into nuclear winter.
When we're looking at the type of power we need, some of those items that you just discussed, what types of infrastructure are we going to have to put in place to support the behind-the-meter solutions?
So you're going to have to look at behind the meter, your own HV rings, for example, because you're going to have so much power that you're not going to be able to do it with MV. So you're going to have to step up. So that brings a constraint on both equipment lead times, cabling lead times, et cetera. So looking at that, you're going to have to look at your power mix and what the power, like Jim was talking about earlier, what that reliability on the power mix brings you. You have to look at BESS and things like that. And so you're going to have a really, almost it's not going to be, hey, I'm going to have all Siemens or I'm going to have all GE units behind the meter. You're not going to be able to do it. You won't be able to get there fast enough. So you're going to have to come up with some designing for what's available. That's going to be a key component to understanding what procurement looks like and that feeding back into design so that you can actually meet the tight windows that you need to do. So those are some of the strategies that you can take to kind of get where you need to be, and also looking at other newer technologies like fuel cell technologies, et cetera, that can, I'll call it blue hydrogen, right, that can provide some speed to market, some new technology that you can put behind the meter.
I want to build on one thing, and I think Lloyd mentioned it, but just expand on it because I think it's applicable to this room. He mentioned that you're buying the equipment first and designing second. That seems a little bit out of kilter, right? Mm-hmm. Especially with the room here. But that's what folks are doing right now. They're actually going out, purchasing the OEM equipment, going back and taking the OEM standard right off the shelf, designing the facility to that rather than designing the facility to procure. And so that's a big shift in our industry that we're seeing right now, and a lot of that's being driven off of the long supply chain issues that Lloyd is describing. It's a very different dynamic, for sure.
Yeah, like the constraint we talked about earlier. So gas turbines, for us, we want to go get the large gas turbines, put in a combined cycle so I can get 1,300 megawatts. Today, if you run to one of the three big turbine manufacturers and say, I need a gas turbine, they'll say, okay, you'll receive it in 2032.
Yeah.
Yep. Well, what does that do to you when you're looking at speed to market technology? I mean, you can buy the equipment now, but by the time you get it and you build it, is it going to be out of date or obsolete and something else has come up?
Very possible, but then you pivot and keep going. But for us, when I put in a gas turbine, I am expecting to get a minimum of about 25, 30 years out of it. Okay. So even as technology changes, what will happen is they'll develop improvements for my assets, and I can spend less money to just get those incremental megawatts as they develop.
And I
was going to say, probably the bigger challenge is that these servers that they put in, I was just listening to one AI CEO talk, it was a couple days ago. He said they have a shelf life of 3 years and their technology's out of date. So you think about it, they're spending billions of dollars for something that has a shelf life of 3 years, right? And then they got to change it out, and that changes out the entire power consumption model of the facility, right? So that's probably, from a technology and perspective, that's probably the bigger challenge, is being able to keep up with the changes at the rack level and at the chip level that are putting a different power demand on the facility, and what does that look like? And you're going to have, basically, you're going to have a rolling plan, engineering design plan on how you're going to constantly change the facility to meet the demand at the chip level.
And I'll hop in here as well and just add some context. Like, we see this in France currently. On the nuclear side, it's cheaper and faster to build a facility, along the lines of an AP1000 or something like that.
Right.
per the 1990 standards and then pay to retrofit it up to the most modern standard when it's completed than to incrementally ask for approvals and, upgrades to the ASME standards and things like that as you go. And so I think that there's a lot of potential in, the 20, 40, 60, soon to be 80-year extensions that we're seeing on some of the legacy plants. I don't know if you have any comments on that, but.
Yeah, we've actually did the life extension going out to 80 years on 2 facilities, and we'll do it with our remaining 6 as well.
That's amazing.
Right. And the last thing I'll just say here is, I think, Jim, you brought up a great point that there's this war going on globally for energy dominance. We talk about energy resilience, infrastructure. We also need to make sure we don't weaponize the procurement process, right? We just talked about, right, that it's basically whoever can prepay, warehouse, and vertically integrate wins.
The other piece I want to build on here is, and the comment is, we've got to look at diverse solutions here, guys. We can't just kind of think about the old one-trick pony to get this power. And the technology is actually evolving quite quickly, right? We're going to talk a minute, I think, on SMRs, but Lloyd, you mentioned BESS, right? This battery energy storage systems that are becoming very prevalent, especially for backup power. That's important. I was in a meeting just this last week, too. We were talking about solar, and solar typically has been about a megawatt per acre. We saw numbers from a technology company that's developed the technology in a way now that's getting upwards of 15 megawatts per acre on the solar side. And so these kind of solutions are being not only explored, but exploited, right? When you think about the integrated, microgrid approach to getting this power to certain types of verticals that are needing the power to grow with.
Well, and, that brings up investment opportunities, right? You're looking at different ways to do it. You've got to look at program structures that you might be doing. And, when we have a lot of venture capitalists out there that are putting together these programs and building these. So, the investment opportunities here, what with these owners, what do you think their return on investments, what are they expecting from that?
Yeah, let me take that one first.
Okay.
So we're in the middle of a lot of that with several developers right now, and they kind of think about this. We probably talk a lot in the room about NPV and IRR, but they're looking at yield on cash. That's kind of the parameter that they're driving here, and the expectations. And I'll kind of quote this in the market for data centers. The big guys are okay because their balance sheets are so good that they're willing to take returns on cash at probably about 8%, some even lower than that. But if you get these developers that are taking a lot of risk on they don't have the balance sheet and they have to raise equity, and they have to go out and use venture capital, to go and get the equity raised and then go again to the developer to get a credit wrap around the rest of the project. And we're talking about multi-billions of dollars for a data center to get built. They're going to want somewhere in that area of 12 to 14%. So it's kind of disparate depending on who is actually providing in that particular market, the actual data center, for example. So it's kind of varying, but that range of 8 to 14% seems to be what they're expecting on a yield on cash number.
Okay.
And I'll just add to that by saying that I think there's incremental improvements that need to be made in this process, right? I think gas is a bridge in many ways, right? So, like, we have a client who, for easy numbers, let's just say, they buy a plot of land in the middle of nowhere for $10 million, right? If you just get it zoned, licensed, regulated, the permitting done for a gigawatt of nuclear and a gigawatt of data, that property's worth roughly $400 to $500 million suddenly. And then, they're going to probably start building the data center first, so they get a will serve letter from the local utility, and that turns it into an asset, like a revenue generating asset, because they have 500 megawatts or a gigawatt of gas, and then they can start selling that back. And as they get construction going, gas is the bridge, right? Nuclear is just a piece of the pie.
Well, and if nuclear becomes a piece of the pie, when does it become the difference between the Department of Energy and the Department of War?
Go ahead, Marshall.
This is a challenging one. So, the DOE, obviously, a lot of these projects are being done on DOE land, and that client I just referenced, right, I think that they're a great example of how you can start getting away from using purely, the sites in Oak Ridge and the places that are right in my backyard. There's a lot of others. And I think that the government's done a great job of kind of hopefully getting us critical by July 4th, if you guys are familiar on the tests at Idaho National Labs right now. But, you know, where are those people going to go once they have operating reactors, right? Maybe it's military bases first, maybe it's, you know, hyperscalers. We'll see. I think the scale of some of these, and I know Andy's definitely more critical of this piece, is, you know, the scale is just not quite there. You know, like, how do you add 25 megawatts together repeatedly to get to a gigawatt, right? It's a hard equation for sure. There's definitely been a divide as, you know, the government's changing structures and titles with DOW now. And I think that, you know, whether it sits in, you know, the NNSA or, you know, Department of Science, or if it goes to DIU, which is the Defense Innovation Unit, right? So military, Air Force applications, it's hard to say where that will land. But I would say that the key appropriations still rest with the DOE, and we saw that with the water bill a couple weeks ago even, just like another $40 billion, I want to say. So I think that power will remain with the Department of Energy, but as we can increasingly see the national security imperative of energy, I think that the DOW will be more interested in that, and they're a prime candidate for behind-the-meter solutions.
Yeah. Maybe just build on it, what Marshall's saying here. I'm already seeing it pivoted over to the Department of War.
Okay.
We were actually in a conference about a month or so ago, and we had quite a few high-level officials in Houston, and a lot of our state reps were there, and we had some high-level colonels in the room, and we're having this same discussion, right? And we're talking about the difference between the DOE and DOW. Where's this all going to kind of land? And, you know, if you're looking at the government side and the fact that AI is a war and this infrastructure supports it, like we talked about, their role and support that DOE has the ultimate say, but we're going to provide the ultimate oversight, because that's how important it is. So you start to see both departments coming together right now, the DOW and the DOE,
Okay.
and kind of collaborating. Believe it or not, there can be collaboration in our government, and that's what's happening. And we'll see where it lands, but certainly the debate's on.
Absolutely, and we'll add to that is, you know, with the recent announcements of Project Genesis and Project Janus, right, so advanced computing and military base installation upgrades, I think that the government is, you know, not all of the demand for AI is coming from Silicon Valley, right? There's a need for secure compute. Governments are digitizing. I'm working on a project in Bulgaria where they're going to sell secure compute back to NATO. I think that those kind of applications are where we're going to see the demand coming, and that is DOW.
Yeah. Thus the Stargate project over in the UAE, right?
They're really good at naming.
Yeah.
And Marshall, when you introduced yourself, you said you insure nuclear. So tell me, and our friends out there, what are the insurability challenges that you're facing on these large-scale energy projects?
Absolutely. So insurance is one of the most boring things, so I'll keep this brief, but I
Hey,
hope you
be
guys,
careful with
this
that.
is a helpful.
I think it's kind of fun. But go ahead.
Well, but here's the thing. It all ties back to financing, right? We, I think, help increase bankability for these projects, and that can be, you know, hot testing, super niche technology performance insurance, or it's builder's risk, right? Everything that you guys are familiar with. With nuclear specifically, you know, construction remains largely the same up until these, you know, turn it on, go or no go kind of moments. And so in those contexts, you need basically every insurance policy excludes nuclear. But the problem is when you start engaging the big reinsurance pools per the Price-Anderson Act and the Advance Act and some of those things, you think you're going to have a partner, right? Oh, yeah, okay, when we get to the operational piece, we'll have coverage. You have to engage these groups very early on. I'm talking like pre-con, like way before even that, like design. They want to engage with you, fully understand it. And I think that's where Newfront comes in, is like, you know, we drag insurance carriers into the 21st century on novel risks to get them engaged on, you know, risks that they're kind of out there on. But if you don't engage these groups early on, they're not going to be there when you need them, because you've, you know, signed and there's limits of liability, some kind of thing in your DOW, DOE, or private contracts, and they're going to push back on that. The other challenge is all of those pools that are able to write, you know, these $500+ million limit insurance policies for nuclear incidents can't be accessed by companies. You have to have a broker to go through that process, unfortunately, and they will send you off. Just go find a broker that can talk to us. And that assumes that if you find about these pools and then they kick you to a broker, that your broker knows anything about nuclear. And I'm not patting my own back here, but there's very few. And so I think the amount of people that are kind of engaging with A&I, not fully, you know, doing the correct due diligence, risk engineering, it needs to be very early on. And so the challenges are truly every policy excludes it, and you need the right partners to help kind of navigate through that.
Well, and it's not just the nuclear coverage part. There's also the fact that the cost of these, right? I mean, they can be, you can start at $2 billion and then you're $17 billion overnight, and their project terms are very lengthy. You know, you can be 3 years or you can be 7 or 8 or 9 years. And entering into those long-term partnerships, not only from the owners, the contractors, keeping your permitting going is, especially if you have to pivot, but your insurers also have to buy on for that, because you don't want to be stuck in the middle and you have no, you know, coverage is ending. So getting that to market, addressing those concerns with everybody up front, I don't think you can ever start too early, because there's just too many moving parts that will affect it.
I completely agree with that. And there's novel insurance now, like really advancing in cybersecurity, but also like even just in IP insurance, right? Like the second you take out a patent, right, nuclear technology goes back 50 to 75 years. But if you make something novel, you need to protect that very early on. And, you know, that protects from, you know, local competition, but also foreign adversaries as well. And so we're working with carriers to kind of build the bridge policies there that will kind of warm them up on nuclear so that when you get to deployment, you know, you can decrease the nth of a kind cost.
So I was going to ask, you know, that hearing this, you know, as a nuclear operator, there are, you know, what do you say, 94 active reactors in the country. I think that's part of why you're seeing some of these data centers team up and co-locate, because we've got the experience, we've got the training, we've got the operators. I would see that becoming more common as we start to co-locate a new nuclear site with a data center.
And I know that, you know, there's some out there that are working on 3 Mile Island, things that are already in place. You know, what's happening with that space?
So 3 Mile Island was a Microsoft play, right? They bought that, but you might say, well, why did they buy it? Are they going to restart 3 Mile Island reactors? The answer to that is no. What they bought it for is essentially the infrastructure, because they don't want to have to go and put all that transmission capacity. And their intent over time, because our good friend Bill Gates is out there kind of championing SMRs and nuclear as well, the intent is to kind of put SMRs on that site and take advantage of the actual infrastructure that's existing there. And infrastructure being, you know, a 7-year delivery time cycle, you know, that made a lot of sense. And then you see AWS going in there. They bought, you know, up in Susquehanna, they bought that nuclear facility. That predominantly was a complete takeoff, right? They basically made a 10-year commitment to go and take all that power. So you see them starting to reach out, right? But I think what Andy and Marshall are saying here, the data centers, again, they want to have grid reliability, right? They don't want to be in the power business. That's not a core competency, nor do they want to build it as a core competency. So if they can partner and the SMRs come, there'll be close coupling with these SMRs and data centers on the same sites is what the vision is.
Right, I'll just add to that briefly by saying that I think this really mimics what we see with airports, ports, refineries, right? You need the energy syndication to, you know, make these private assets work for multiple opportunities.
So when you switch, when you build that, now you're a nuclear operating facility. And Andy, how is it operating a nuclear operating facility? That's a lot harder than just operating, you know, a data center that's hooked to the power grid.
So I think the interesting thing is going to be around SMRs, if they're going to require the same training and everything by the NRC that you do for a current large nuclear facility. Because currently, every operator in a nuclear plant has a federal license that's they've qualified for with the NRC. They maintain it, routine testing. Standing up a new training program without having any background in it, I think is going to be extremely difficult. I would foresee you're going to have some companies out there that have the expertise and step in and fill that gap. You're going to have others that'll say, hey, you know, we're in your backyard. What will it take for you to come and provide the operations for us?
Right.
But it's going to be interesting to see if they change the regulations and how, as to what impact it'll have.
And I'll just add to that by saying that, Lloyd and Jim, you guys are really the experts on, workforce development and all that. But I just want to highlight a few of the models that we see with these nuclear companies, right? I know companies who will build one reactor, then license it out, different people will operate it, they'll be trained on it, and they will run with it. There's also the polar opposite of that, where companies have taken internal full architecture EPC firms, and to be honest, they're probably not hiring the top 100 people in nuclear from Fluor, and they're going to own, operate, design from end to end. And that's fantastic. It could decrease nth of a kind cost, we'll see.
Yeah.
But that's totally different from a liability framework, just because, there's no more finger pointing. It's all internal, right? You can't sue yourself.
Yeah.
I don't know if you have any perspective on that, Angela, but.
Well, obviously we're concerned that there's not enough skilled manpower out there to operate these facilities. There just hasn't been enough. We're not, we have a problem with skilled labor as it is when it's non-nuclear, and trying to get those folks up, trained, and know what they're doing gives everybody pause, right? We know that there's a lot of contractors out there and owners that can be plant ready pretty quickly, but then when you're ready to add the power, that puts a whole different dynamic for it. And it does give us some concern on long range. Are we going to have the skilled workforce to support this? And what do you think about, what's the public perception of nuclear today? Because in my lifetime, we grew up hearing, Fukushima, 3 Mile Island, Chernobyl, but I don't think the same perception is following through with younger generations.
So we saw a turn a few years back when they saw that power was getting critical. And at that time, you were seeing a lot of the nuclear plants saying, we're going to shut down in so many years. And some of them did. How many of them are starting to try to either pull that back? So I think like Diablo Canyon in California, they want to keep it running. I look at Palisades. Holtec was hired to tear that site down, and now they've determined to repower it, get it back up and running, and then add 2 SMRs to the site. So I think with the criticality of getting new power, it's getting a lot more support in the political arena as a viable option, and that's definitely helped.
Okay. All right. Let's see what else we have here.
While you're flipping over, I'll just say that community trust drives your schedule, right? It is the end-all, be-all, right? And you're dealing with, local police forces, schools, education, getting the skilled workforce, but you're also dealing with under-resourced and highly influential people, right? Government offices, these places move slow. Local electives or officials especially are under-resourced, right? And so, yeah.
I want to comment on the labor piece, because
Okay.
I don't see us solving that anytime soon. We've been working on it for 25 years, guys, in this room, right? So the one piece that I will mention is that a lot of this is all conducive to off-site construction strategies that we have to be thinking about in a real way, whether that be lean, modularization, combined together. The data centers today, I'm going to go back 5 years ago, modularization was just kind of something they talked about. But today, it's all modularized. When we think about all the mechanical equipment, the integrated MEP, think about the IT racks being integrated with servers. It's all modular, rack and roll into the data center. What that gets them, and it helps on the assurability side as well, it gets them schedule acceleration, but more importantly, it gets them schedule predictability. And they get safety and quality on top of that, and so that's a winning strategy. So when we're pivoting over to these other new technologies, that has to be something that gets adopted.
Yeah.
Otherwise, we're going to find ourselves still complaining about labor, but don't have a strategy to mitigate it.
So how many are enough? So, like I said, every week we get submissions in, and that's just our company. And there's other companies out there that are getting the same. And it's, the projection for construction is huge. When, and Jim, you mentioned we're eventually going to catch up. When are we going to catch up?
Well, I think you said it, Andy, was 7 years from now, right? We're going to be catching up. But I think it's in that 5 to 10 year window. I think people are getting it.
Okay.
And when you look at, you know, the McKinsey's of the world, the Boston Consultings of the world,
Right.
and they're taking a look at future projections, and, you know, they have do some really good research. They're coming up with that same kind of validation of that 5 to 10 year period, that we're in a crunch today. Everybody recognizes we're in the crunch in the U.S. They understand the importance of that relative to infrastructure, and thus they're starting to pay attention to it. It doesn't mean all the constraints are being dealt with, because we still have opportunities there, but they're still predicting that we're in that 5 to 10 year window where we believe we'll be closing the gap significantly.
Okay.
So you heard a little bit of it yesterday of the new generation coming out from high school and going into trades and getting them when they're in middle school. I'll give a shout out now to NCCER,
Yeah.
and some of what they're doing is look around your community and see how many high schools have re-implemented the industrial arts. They've put in welding programs, pipe fitting, carpentry, things like that, and that's the start of it, where they get to see it, start learning it, and by the time they're out of school, ready to go into the profession, they've got a solid base.
Well, we're going to need that, you know, and, you know, like you said, Jim, we've been talking about this for 20 plus years, and a lot of kids have grown up in that time frame, and I agree, and NCCR does a really good job of that, bringing it to the local schools and getting younger people involved. So with, you know, what we're seeing today, what we can expect in the future, it's, like I said, it's not just data centers. I think, you know, Marshall, you indicated you had a customer that was going to build a facility. They get there, there's not enough water or power to support the facility, and it wasn't even a data center. And the infrastructure that has to be put in to support the construction that we're doing. And Jim, you had mentioned that, you know, the community worries, who's going to pay for this? And so getting started early helps as much as possible, you know, making sure we've got permitting in place and approvals. And there's still communities that don't want this in there, right? They don't want the noise, they don't want the traffic. But, you know, if we're going to move forward in the future, we're going to have this. Are there any other suggestions from the panel on how we can help make this a smoother, better process for not just the community, but our contractors, our owners, our insurers?
Yeah, I'll start. It's all about engagement.
Okay.
And, you know, many of us in this room, if not all of us, have done projects our whole careers, and we know the ones that go well is when we actually engage our stakeholders very, very early in the process. And a lot of owners see that as a cost versus as a value. Unfortunately, they're wrong. It is a value. And so you got that part of our community here in this room, but I do want to build on the community piece one more time, because it is so important. And we're experiencing that today. I'll share one war story. I was actually building a data center up in Finland, and we were in the middle of site selection. And we were going in there, and we had put into the permitting office what our design was. The community got a hold of it. Lo and behold, the individual who wrote the Finland national anthem was a near neighbor. He came in, and they were protesting no generators in my backyard, because data centers run with a lot of backup generators.
Yeah.
And he said, you are not building that data center here unless you take those generators out. So this goes back to the community right to operate. Well, we pivoted, and that's where the best technology was first deployed to replace the technology in terms of eliminating the generators. And that was a win-win for the community. Then everybody viewed it positively. But it's all about engagement and giving back. We're on a project right now, and where the actual developer, and Lloyd is part of that project as well, has actually asked every one of the participants in that project. We're doing the town meetings, as we talked about, but they've got to give 10% of their actual earnings back into the community to help provide support. This is a small community of several thousand people. That sends a huge message. And so when the Sierra Club shows up or Greenpeace shows up, and they do in these rooms, we're able to mitigate them trying to influence that they're taking your water, they're taking your electricity, you're subsidizing all of this, and now you have the community as a stakeholder on your side. That creates the real win.
Yeah, I would agree with that. You get a lot of outside influence in these. Just a couple of weeks ago, I was in one project and city council meeting, and we had somebody show up with a video camera and started videoing themselves talking, and they weren't even part of the community. They were completely from outside of the community, and trying to agitate and saying, well these folks have they have a tax abatement. Well, yeah, they have a tax abatement, but there's a fee in lieu of tax, so that there's consistent cash flows both on the city side and both with the developer. And so, a lot of folks will try to take some information, misconstrue it for their own uses. So having that community engagement will mitigate the outside influence risk for sure.
Yeah, I would put it early and frequent community engagement and early collaboration with all the partners that are part of the team.
And I'll just add one last thing with an anecdote. I was able to graduate from the #1 aerospace engineering school without ever touching or going into a machine shop. That's a problem, but we also need community engagement to make engineering and construction cool, right? We spent a lot of time talking about this yesterday in our little workshop at the end of the day. How do you get people to be motivated to be in construction, be in these fields? I worked at a CNC shop in high school, and within 3 months of not knowing anything about anything, honestly, because I was in high school, I was able to start working on parts that were going into Lockheed Martin, and that was amazing to me. And so, yes, it's education, yes, it's community engagement, showing off the project, but also all of those subs and people who are providing things will hopefully eventually be in that community, and it's on the owners of those groups to take chances on people, and that'll help get that next, what I would call a blue-collar workforce, right? You don't need a college education to make a great living in this field, and just making those pathways really clear, I think, is really important.
Well, and that brings me back to something I should have asked a little bit earlier on where developers, and somebody mentioned this, that buying the people from a contractor, and going to the developers going to contractors and hiring their design staffs to become, now it's not just the developer, but now they're integrating design and looking at putting energy components into their program. And that's really tough because we don't have as many people as we need already in our field. But if developers are doing that to build these plants and locations, how is that affecting the risk as well? Because now it's not just an owner, it's an owner, developer, contractor, designer, all under one named insured.
There's definitely insurance structures that will deal with that. I think the most important thing comes back to timelines, right? We talked about gas turbines, right? The reason why nuclear has a chance is because it could deliver faster, right? 5, 7, 8 years. That's the reason why we're having this conversation. And so from a timeline perspective, bringing all those things in-house could speed up the execution. Mm-hmm. But you're also not leaning on, an EPC who's working on 50 of these sites at once. Right. You're doing a one-off. And so there's kind of two kinds of companies in the nuclear space. How many people have made money off Oklo stock recently? Right? They do everything, right? They do waste, they do power generation, and they're going to take a lot longer because they're vertically integrated and they have to prove out every single constituent technology. Snow Lake is the same way. Whereas, Radiant or General Matter or some of these companies, they have the design for the SMR, they do one thing really well, and then they need to build that ecosystem. We talked about the energy syndication, right? Just coming together on these projects, right? Having land that is technology agnostic, right? They have TerraPower, they have Radiant, all these people as partners. I think that you need to keep timeline top of mind. And so, yes, there's new risks that come in, the finger pointing from an insurability perspective. How does that, get handled in other insurance markets? But I think that ultimately those people will be a little slower, in my opinion, because they have a bigger staff, they can do it, but they have more to do. And they need to trust the expertise of their partners, in my opinion.
Yeah. Jim? Okay. So we have a little bit of time left for some questions. If there's any, we have one back here right away. So. Can you hand him the mic? Thanks.
Yeah, sorry. Can you hear me?
Yes.
Okay. So there's this enormous pipeline that is ever growing of projects, both for data centers and for, let's call it auxiliary, power, independent of the grid power projects to provide adequate power. So traditionally, power projects have been delivered using an engineer, procure, construct delivery method. Given all of the changes we've seen in the construction industry over the last decade, where collaborative methods have become more widespread, do you foresee any methods other than EPC as being important to the delivery of those projects? And the second question is, as far as an actual project in the overall direction of what you've been describing, I think it's called Project Matador. It's in Amarillo, Texas, across or immediately adjacent to the Department of Energy's Pantex plant, which has been around since the 1950s. It's this huge 11 gigawatt facility that Fermi America, which I think was founded by former Texas Governor Perry, has been leading. Is there anything of comparable ambition that you see, coming forth to that? I mean, I know that to start with, I think they purchased $1 billion worth of gas turbines in various phases to, to power that site before any modular reactors become available. So anything that you could comment on with respect to those two general questions, I'd be interested to hear your response.
I can hop in on the second one.
I can hop on the first one and the second one. I'll take the first one. So, yeah, I'm seeing a change with the power and the data co kind of integrated together. We're working on a couple of projects right now that clearly requires the integration, right? And you might have a separate organization that's working for the developer. This one project is a real project. It's not quite where you are, but it's kind of in Central Texas still, 8 gigawatts. And we've got all of the kind of challenges of getting the microgrid positioned up in time for us to actually get the data co going. But we're working as one team. And we have the same general contractor cutting across both the power side as well as the Dataco side. So that gives us the integration. The subcontractors have been aligned to be part of the team. We don't call it IPD because that's kind of a nasty word, but we do have a very collaborative approach to the project where we are one team working towards the one goal of getting that data center first data hall out with megawatts to client. So you do see those kinds of strategies playing out right now because we know that if we don't work together on this thing, we're just going to be pointing fingers at each other and everybody's going to lose. So recognizing that, that's the way we're setting a lot of these up on these larger gigawatt sites.
On the second point, about Fermi, so just for quick context, they went public a couple months ago with a $39 billion market cap, and I believe since then, the first 90 days, it lost 75% of its value. And so they have a remarkable ability to attract and raise capital, institutional retail investors, and I think that will play very well for them in the long term, right? Because a lot of these projects can't get off the ground. They've been able to get the land, fantastic. They're working on zoning and licensing, fantastic. But I'm just worried about the hype machine of some of those things and the huge value that's created and destroyed by these big announcements, right? So in my opinion, Fermi raised $39 billion off of a PowerPoint. I think they're a long ways away from true deployment, but projects of the 11 or 8 megawatt or gigawatt scale are coming in droves.
Yeah, I think Fermi actually caused a black eye quite a bit on the industry, right? When the anchor tenant, when that deal fell through, it made a lot of other projects questioned. And it made the finance community really nervous.
Yeah.
And so I think that project actually caused a lot more problems than good.
And I'll just say, I think there's more black eyes coming. So Newfront cannot share any details, but we're working on a DSPAC and IPO, and I know of at least one other that are all those kind of pump and dump models to raise capital. And I just think that, you know, we signed PPAs, and we'll talk about this briefly, but, you know, PPAs don't even have a price attached anymore, right? And so it's this hype machine of, you know, Microsoft, Google, et cetera, signing some agreement that they don't fully understand, and then, you know, you raise your next round. It's very Silicon Valley centric, and I don't think that's the model that's going to get us power in the grid as fast as possible.
So Jim, in my world, let me ask you this real quick. IPD, Integrated Project Delivery, is not a bad word. So, you know, so I would just like to know, you know, why you
I say
why you
that
feel
because
like
it's
that.
not utilized to the extent that it needs to be.
Okay.
So we're in alignment.
Okay.
It's just not happening, and people are using hybrid approaches to it.
Okay.
But anytime we could have an IPD approach where we have a balanced risk and reward, that's a good project.
Okay. All right. Next question.
Good morning. It's certainly a great time to be here today, and I appreciate all the great conversation.
Can you? Is it on?
So my name's Don, and in 1981, I was called into a nuclear power plant, and it was 2.5 years behind. We had to put together a plan to make it open on time. I was a general superintendent, and we put together a plan, and it was rolling 410s. So rolling 410s make operations go 24/7, 365. People work 4 days, they go home, they rest 4 days, they come back, there's no burnout. And we roll over to the night shift, and you're working 24/7. So that gas turbine plant that wants to take 7 years, they can do it in 3.5 if you put them on rolling 410s. It's a great concept, and it's proven, and it worked. And I think everyone in this room needs to consider that, especially the owners, because I'm not sure if we're chasing, in this war that we're in, and I believe we are we chasing the schedule or are we chasing money? If we're chasing the schedule, this will work. And the Nuclear Regulatory Commission came on board, all of the testing facilities came on board, 3M came on board, and we opened that plant on time. So whatever timeline you have right now, cut it in half with rolling 410s. I just wanted to share that, and I certainly could talk a lot more about it because I helped develop the plan, the supervision, everything that needed to happen to make that work, and I just feel like it's time for everybody to hear that. And procurement is big, right? They have to come on board too, so everyone goes on rolling 410s. Every vendor, every supplier, and they did, and they can again. Thank you very much.
Okay. Any other questions before we close it? Yeah, Rob.
It's Rob Wagner, Procter & Gamble. It's not necessarily going to be a question. I think you had talked about the possibility of how could we locate mini nukes or whatever that we're going to be building, and Homeland Security came up as a conversation, terrorism or whatever. We were chatting here, and I was thinking, okay, every single city, every single community has a National Guard center, so why wouldn't we locate the power on the National Guard site? And therefore, but that's now collaboration between energy and private sector and public sector, but it would be a position where it'd be, I think, mutually beneficial, and you have the security built into the situation already. That might be something for your team to discuss.
Great point, Rob.
Yeah, good point. All right. Any other questions? Oh, we've got one in the front.
Yeah, for Angela, for you and Marshall, around ensuring nuclear, ensuring the next AP 1000 is a whole different story than ensuring some of these advanced technologies that, whether it's a micro reactor or a small modular reactor, that are completely different technologies. And, quite honestly, with the timeline of going critical by the 4th of July. You know, it's very, very challenging. And could you talk about some of the concerns you have as an insurer on technologies like that?
So, Marshall, I'll let you start because you're.
Yeah, absolutely. So one thing to just quickly, like, you know, level out on is the technologies we're using now were created, you know, 50, 80 years ago. And we have some kind of actuarial history, which is what the goal of what we're trying to build here from, you know, the nuclear navy, things like that, but it's pretty limited. The other thing is the technologies have been changed for unique safety characteristics, right? So fusion from fission, right? Fusion can't chain react. It cools down if it goes bad. That's an easy one. Fission's a little different. There's two technologies I think that are worth mentioning here. One is on the fuel side. So TRISO fuel currently is cost prohibitively expensive to create, but it's basically these fuel pellets that burn instead of rods. And, you know, technical people on the panel can correct me, but for long story short, can't really chain react and go critical outside of what's expected. And then there's also like molten salt reactors, right? MSRs, which gets confusing between SMRs and MSRs. There's a lot of different technologies there, and they also cannot, you know, Chernobyl, for lack of a better word. And so I think that what we're working on is kind of helping introduce these companies working on these technologies, explaining the unique safety characteristics, whether that's higher temperature, lower pressure, or some, you know, combination therein, to help them kind of understand how the industry's advanced. And yes, there's still risk, but I think that tech companies, the technologies we're using now are much safer, you know, passive cool down, all these things, and that's by design. And I would just say that, like, the chances of something really bad happening again are not zero, but they're much lower. The chances of a lot of money being wasted because an experiment fails is high and possible. But will that lead to a nuclear incident? My answer would be no.
And insurance companies, obviously, with all this new technology, we have to get our arms around that. We have to understand what's happening, and that's why we rely on, you know, the people in the industry we know, you know, like Andy, to help us understand on running these facilities, what the exposures and the risk are, and like Marshall and Newfront and what's coming up and what technologies are changing. But yes, are we going to have a policy by July? No. So, you know, but each company has its own treaties and, you know, restrictions around nuclear. So I think those are all things that are going to be needed to work on in the years going forward, because our whole environments have changed, and, you know, the market's going to have to change with it. And I think we are out of time, but I want to thank our panel, Marshall, Andy, Lloyd, Jim, and appreciate all the insights, and thank you to the audience. Okay?